Welcome to episode 111 of the Actual Astronomy Podcast. This is Deep Sky Observing in Leo, Virgo, and Coma, Berenices, or Berenices. I'm Chris, and joining me is Shane. We are amateur astronomers who love looking up at the night sky, and this podcast is for anyone else who likes going out under the stars. And how is your spring astronomy going, Shane?
It's going well. Lots of double star observing so far. Going to add some variable star observing. And spring is quite famous in amateur astronomy circles for galaxy hunting. This is the galaxy season or the start of it. And there's, especially for northern observers, it's sort of a fleeting opportunity for Virgo. It doesn't stay too prominent for very long for us because we're getting closer to perpetual daylight in June. But this is a great time of the year. And again, for us in more northern latitudes where we have colder winters, it's also sort of just a welcoming warming of temperatures, and the amount of time I spend at the telescope goes up exponentially from where I was over the winter time.
Yeah, I'm really not much of a galaxy observer myself, so I'm always more into the other seasons, I guess. So here we are at this time of year. There's kind of like four seasons. Hey, like we have the spring season, which we call galaxy season. The reason for that is that, in our disk of our Milky Way galaxy where we reside, this is the time of year where in the evening we're looking out of that disk and sort of past the lowest density of our Milky Way arms. And then as we move into the summer months, we're looking towards the core of the Milky Way, kind of towards the center of our galaxy. So we're looking at a different set of objects being prominent, which are mostly like star clusters and nebulas and some globular clusters, and a lot more stars, the bright band of the Milky Way itself and the dark bands that cut through it. And then as we get into the fall, although we get some galaxies, we're kind of getting more into that sort of Milky Way of the winter sky. Sort of there's a bit of a Milky Way in the fall sky, and then that just progresses into the Milky Way of the winter sky. And so mostly I'm kind of like a Milky Way observer, but I probably looked at a couple thousand galaxies in my time or something like that too. So
yeah, I'm very similar. I prefer to look at a lot of our own galaxy objects. And I've looked at a number of galaxies through my time, but I find, like with galaxies really need aperture, to bring out the detail. Otherwise, they really just look like faint fuzzies. And at the largest aperture I've had is 12 inches, a Dobsonian telescope, and it showed some amazing detail in multiple galaxies. But the amount of bright galaxies that really show detail, it's a finite number, and you do reach the end of that. And then it's either, step up an aperture to see additional detail in other galaxies. But even that is, you get to a point where you've kind of exhausted that as well. So I just don't look at galaxies as often, but I still do enjoy them. And even in small refractors, like sorry, I hit my microphone stand. Okay. Some galaxies look outstanding, even in smaller apertures. So we'll probably cover a few of those today.
Yeah. Well, Mike, he's getting his 15-inch working. And so I look forward to having some views to that maybe later this spring, if we ever all end up getting vaccinated. We were talking about that just before we went back on. We're on vaccinations are on hold here, so we're kind of sitting around waiting to see what happens over the next few weeks.
Yeah, this is an aside, but I don't know if you saw on astrobysell.com, there was a 25-inch Obsession for sale for $6,500. And it has like all of the bells and whistles with Argo Navis, or no, Servocat and Argo Navis. Great price. There's a sale pending. That's like I think that's a $20,000 US telescope brand new for a 25-inch.
I really want one of my friends to buy that telescope.
Yep. Yep.
Because
I do not want to own something that requires a trailer to haul around.
that's like owning a couple horses. I mean, that's a lot of. I've looked through the 25-inch Obsession, and it's they're great. Like it's really cool. Like it is cool, but you know, it's kind of like, yeah, it's kind of like going on vacation and staying in an expensive hotel for 2 or 3 days, and you kind of you get the experience, but you can kind of don't need to live in that environment. And that's kind of what having a massive telescope like that is like, in my opinion. It's pretty cumbersome, and it's a responsibility, and it's a lot of heavy heartache, if you ask me. But yeah, when I go to the star party, I'm right there. I'm climbing that ladder, and I'm thanking the owner profusely, and really given good credit to them if I publish observations through the gear, because I definitely appreciate that. But not for me to own such a monstrosity. But yeah, like I concur with you on the galaxy front. I remember when I first became proficient, like I got a few years behind me in observing, and I had an 8-inch telescope, and I had observed all like the Messiers and different brighter NGC galaxies, and I just wanted to see like how many of these things can I actually see. And I was a much younger person, and had that 8-inch out in the backyard, and close to magnitude 6 sky, and I could just sit there and find a galaxy and take an observation and find the next one. And I remember spending night after night after night observing dozens of galaxies every night, just because I was kind of really enjoying the fact that I could actually star hop and find things in the nighttime sky pretty quickly. And after several nights, I kind of almost have my fill of it. It's like once you've seen 1/10 or 11th magnitude galaxy through an 8-inch telescope, they do kind of all start to look the same. But it's still neat. It's still fun. It's still challenging. But that's when I kind of started getting into the smaller scopes and looking at some larger things. So let's start with Leo, Shane. I can talk a little bit about the myth history and stuff like that, but I didn't know if you had anything to talk about first about it.
No, I think the introduction has been sufficient. Like this episode really is about some prominent constellations in the sky right now that are in the south or kind of southeast,
Yeah.
and features a lot of galaxies in that region of the sky. So let's get into it.
Yeah. So as you were saying, and I think that's a great place to start, is how do I find these things? If you're just kind of maybe just want to find Leo, for example. Well, right now in the evening sky, wherever you are on the planet, and this is like more for the northern hemisphere, I think you can see Leo probably getting down to I don't know how far into the southern hemisphere. You should see it a fair ways down, because it is a zodiacal constellation. The ecliptic runs through it. But it will be upside down. But from here anyway, in the northern hemisphere, there's the bright star Regulus, and it's going to be passing basically at its highest point above the southern horizon in the mid evening. Like here, it's around like maybe 10 or 11 o'clock is when it's at its highest, and it's at the end of this large sort of question mark feature. And then just about, I think it's about maybe 10 or 20 degrees to the east is a triangle. So these are kind of prominent star patterns in the night sky. And sort of together, if you drew lines, they say like that kind of forms the line, although I really don't think it looks much like a line. But they are prominent patterns in the nighttime sky.
Yeah, they are. And I agree, while I don't necessarily see a lion in this constellation, this is one of the constellations where I do see like an animal, right? It could be a dog, it could be any kind of four-legged creature, but I can go with a lion and be okay with that.
You know what I think it looks like?
What's
I think it kind of looks like a mouse.
a mouse?
Sort of like pointing the other way. So I kind of see the front part, the
Oh,
triangle is like a
yeah,
little
yeah,
mouse nose, and then I kind of see the tail is like it's sort of like hunkered
yeah,
down and like
yeah.
maybe sniffing for cheese, and then the tail is anyway. We're not going
I,
to redraw the sky.
no. I've always seen it as like a pharaoh, kind of like how it's down on all fours. And anyway, yeah, we're not going to redraw it. So carry on.
but people can make their own patterns. So, you know, in the history of astronomy, you know, all cultures have had their own patterns in the sky, and sometimes different cultures, for whatever reasons, have shared the same mythological creatures in the sky. So in Babylonian astronomy, which really comes out of you know, I think it's the area in and around what was Samaria and sort of modern day Iraq, they did refer to this as the Great Lion. And the bright star there, Regulus, as we talked about, stands for the star in the lion's breast. So what's really interesting about early astronomy is that they didn't have the names for the stars, for the most part, with some exceptions. They would just refer to the stars positionally within the constellations. They kind of had them more closely tied in. And then it was later on with the Persian astronomers, people like Albir al-Sufi, who actually put names to those stars, and that's why we have you know, Leo as a constellation, and maybe with some Greek mythology mixed in as well. You know, Leo represented the monster Humbaba, who was killed by Gilgamesh in that Sumerian poem. But you know, when the Persian astronomers came along, they gave it those names. So that's why you might have a constellation like Leo or Leo the Lion, and then you have a star that's called Regulus, you know, which was placed up there by the Persians. So, but as far as like the mythology, I'm not that familiar. I remember reading Gilgamesh when I was in school, but that's sort of the extent of it. So I don't know if you have any other history you wish to add, but I will say this, is that Leo the Lion is one of the zodiac constellations. That means the planets will pass through it. That means the sun and the moon pass through it as well. And it means that eclipses of all types can occur there, occultations, and you know, and because of that, you know, you should be aware that if you do eventually see like a bright planet or something, or the moon and Regulus will often pair up. I think they pair up later on this month. Do you have anything to add to that, Shane?
No, nothing to add.
All right, just taking a drink of water there. All right, so we'll talk about Regulus for a quick second. Have you ever observed Regulus? Like, have you actually gone out, pointed a telescope at it, and observed it before?
Oof, I don't think so. I would have to check my logs, but that does not stand out.
So I have, and this is why. So back when I lived in Ontario, this is about a dozen years ago, I really wanted to see the dwarf galaxy Leo 1, which is right beside Regulus. And it is really tough to see, let me tell you. And so my friend Clark Muir, he's the chair of the history committee for the RASC. Now, back then, we were just, you know, two guys that observed together. And we went out. He had his 12-inch and I had my 5-inch. And I think he might have had an occulting bar, or maybe I did. I can't remember. Anyway, we tried a whole variety of things, like just using eyepieces with sharp field stops. And we did end up confirming that we did see it, especially going back and forth between my 5-inch telescope and his 12-inch Dob. You know, they're two very different instruments. The refractor might have been a little sharper, but didn't have the light gathering power. And you could definitely see this little glow just off to the side, and then kind of I think through the reflector, it was like on the top or something like that's differently oriented, but you kind of look in and you could kind of see that sort of same faint glow. Now, if you're just using one of the instruments, you might not be so sure, because you might think it was some sort of reflection or something, or scatter in the optical train. But by going back and forth between two very different instruments, we were able to confirm that we saw Leo 1, this dwarf galaxy, right off of Regulus. But have you ever seen Leo 1?
No, I have not. To be honest, I can't even say I've tried for it. So, you know, as Wayne Gretzky says, you miss 100% of the shots you don't take. So.
Yeah, and I mean, to be frank, like we missed a lot of the shots at first.
Yeah,
So
yeah.
not only is it very faint, and it appears as this super faint patch, but it's also next to this really bright star Regulus, which is a first magnitude star. So, and it wasn't even discovered until the 1950s.
Hmm.
When they took those photographic plates, the famous Schmidt camera photographic plates on polymer, with the 48-inch National Geographic camera. That's when they actually ran across it. But you do see lots of reports. People using 4-inch reflectors. You see reports of people using 3-inch refractors and actually being able to see it. So actually, being able to see it in a 5-inch refractor and kind of side by side with a 12-inch Dobsonian, and I got to say that's what we did on those nights. I think it took. I think we kind of thought we saw it maybe the first night. The second night wasn't as good, and then the third night we had a better night and some experience behind us, and we were able to see it. And yeah, it wasn't easy, and kind of on those nights, it's sort of good and it's bad. Whereas you spend all night, sometimes several nights, trying to see one thing. So everybody else is they're looking at all the fun stuff and brighter galaxies and maybe some of the summer stuff that's just on the horizon. And oh, I'm looking at this cluster or this other galaxy that's bright and I can see the spiral arms, and here we are. We're just trying to see something at all. And sort of, uh, more like work, I guess, is what it comes down to. And it's very close. It's just 12 arc minutes from Regulus itself. So anyway, but could be something to try for. People are saying they can see it in instruments as small as about 70 millimeters. So
Hmm.
from a dark site, you're
Yeah.
76. You'd have to get to a really dark site, but you might stand a chance at seeing it.
Yeah, it looks like it's a decent size too. It just, yeah, very dim, and then the brightness from Regulus would have to be controlled. But yeah, that
Yeah.
would be an interesting challenge.
Yeah, so probably your best bet, and the thing that I found worked, was using a good eyepiece. I was using the Pentax XWs, and they have a very sharp field stop. So what I would do is just get Regulus outside of the field of view, and then my 5-inch apochromat doesn't have a lot of scatter, and you can see it. Yeah, but it's going to be one of those things where you're gonna look, you'll spend an hour or so on that, and you'll kind of, I don't know if I saw it or not, and then you'll have to come back to it a couple more times. So anyway, that's Regulus and the Leo 1 dwarf galaxy.
Yeah, good challenge object for folks to give a try. Like you
Yeah,
said, though, dark sky is a must for that one.
yeah. Now I also looked at a couple more things. There's a lot of really faint galaxies. We'll talk about the galaxy clusters here in a few minutes, but there's some bright objects like on the image I have on my screen here. I have M66 on the right, but then on the left there's this. I think it's called the galactic horseshoe.
I'm not too familiar with that.
Yeah, I don't know what you need to see this. I'm guessing probably like maybe the 25-inch obsession that you talked about earlier. This would be a good candidate object for that. But even that, I don't know. It's pretty faint. What we're actually seeing in this image is there's a fuzzy, bright area, and that is a foreground galaxy. And I think what happens here is that the light from the background galaxy kind of gets bent around it, and it forms kind of what looks like a horseshoe with sort of a bright fuzz dot in the middle. So that's what that is there. But I think it's called the galactic horseshoe. But I don't know how faint this is. I think this is into like the 14th magnitude or something like that, or definitely you'd want an instrument that is easily able to see into the 14th or 15th magnitude to begin seeing really much of anything here.
Yeah, that would be tough. And I'm just looking for some details to see if it is visual or if you need, cameras to take that in, or how you would observe that. But, I guess that's also referred to as the Einstein ring, I think, isn't it? The like the galaxy lensing or whatever that occurs. But anyway, I'm going off on a tangent here. Carry on, my friend.
So then we have the Leo triplet. Now, am I recalling this correctly? Did you actually go out and observe the Leo triplet like not that long ago, or was that last year?
That might have been last year. I think, oh gee, I can't remember who, but I think one of our listeners observing reports that we received, within the last few weeks,
That was it.
talked about observing this recently. I can't remember who that was though.
Yeah, yeah. Our apologies for that. Your name didn't stick in my mind, but your observation did. So my apologies, but that kind of inspired me to kind of put this in here. So, but you have observed the Leo trio before, Shane. Do you want to just talk about this a little bit?
Yeah. So all three, I think, well, let me just take a look here. I believe all three are Messiers, or is it just two Messiers? Yeah, just two are Messiers. One is an NGC. So it's Messier 65 and 66. And then the third one is NGC 3628. They're quite close together in the sky, and they're about 35 million light years away. They're all spiral galaxies. One is like edge on, so you see some brightness, and with larger apertures, you may see a bit of the dark dust lane kind of cutting through the middle, but it really just looks like kind of a line of light.
Yeah.
The other two are a little bit more face on. Now, one of them is more face on, so it'll appear probably a little larger. The other one would be at, I don't know, I'm guessing maybe like a 30-degree angle towards us. So
Sounds good to me.
It's going to be, slightly bulging in the middle. But what's interesting about this triplet is like they're all galaxies, but we have different perspectives looking at these galaxies, which is kind of neat because you have face on galaxies, you have edge on galaxies, and then you have others that are like in between that, and you get all three in this one slice.
Yeah, and this actually is a pretty easy area to find. So if you have a telescope and you can find that sort of triangle pattern, on the eastern side of Leo, it's just almost those stars don't quite point to it, but there's like a line of stars, and it's just left to the line of stars that come off that taller side of that triangle. So anyway, you can find a map at iau.org in the constellations section, and the M65 and M66 are marked there. But they're actually fairly easy to find. And as far as my observations go, I think this was the first set of three galaxies that I'd seen. Of course, M81 and M82 up in Ursa Major I had seen together, but this was the first time I had seen three galaxies. And for some reason, I'm not sure if I recall the first time I saw M81 and M82, but this set of three galaxies, the Leo triplet, this really stuck out in my mind for some reason. I remember my first observations of them because the Messiers M65 and M66 are quite bright, and I knew the third one was there. And I was just in my backyard, which is reasonably dark, like the backyard I had when I was doing this observing. And then I kind of knew that other one was there, and I kind of had to use averted vision from my sight on that particular night to see it. And so it was kind of a bit of a skills growth and a learning experience for me, and kind of carried that through in my observing since then.
That's awesome.
Yeah. So moving along, we've got variable star here. Now, have you observed this one? I think I have observed this. It's funny, I had said like I'm not a variable star observer, and then I start looking at, and I know even when Stella was talking about this one last week, I didn't put it on my short list. I'm like, oh, I've observed that star because I think it's this is a carbon star, isn't it? A red star.
Yeah, it's definitely a red star. I'm just reading some notes here on it. I'm not sure if it's carbon or not.
But it's very red.
It's a red giant. Yeah, it's a red giant near the end of its life. So I'm just reading from the AAVSO website. So on their website, as Stella, I think she referenced this last week, that they have a variable of the month. And this just happens to be the variable of the month, our Leonis. And which
is appropriate because that changes every month.
Yeah, there you go. So the radius of this star is about the same radius as Mars's orbit, so quite a bit larger than our sun, but that is typical of a star's life. As it gets towards the end, it turns into a red giant and it swells considerably. Its brightness changes by a factor of 250 times over a period of 310 days.
Yeah.
So quite a range. And uh, what does it say here? At its dimmest, it may be difficult to see in binoculars.
Yeah. 11th magnitude. That's
Yeah,
pretty faint. Yeah.
that is pretty faint. Yeah.
For binoculars, anyway.
Yeah, totally. Yeah.
Yeah. So it's been known for a long time. So it was J.A. Koch of Danzig who observed it first in 1782. And it's a long period variable, and it was only the fourth long period variable known, and it's just 5 degrees away from Regulus. So this is one of these examples of where you can go from being a beginner to getting some pretty good astronomical observing experience as time goes on. So if you're just beginning, you can use maps from like skymap.com or skymaps.com, and they'll tell you when the moon is going to meet up with Regulus. And so then you can discover Regulus by kind of sorting out which night the moon is going to pair with Regulus. And kind of we're making these to kind of be used into the future. So I don't kind of want to give any specific dates, but just go to skymaps.com, and if it's in the spring, there will be times when the moon will pair up with Regulus. And then kind of going from there, once you know which star is Regulus, then you can use your binoculars to find R. Leonis. Maybe you can join the AVSO and do some R. Leonis observations for its magnitude. You can also use a telescope. You get a telescope, you can then start making telescopic observations, and most telescopes of 3 inches or more should be able to get down to 11th magnitude from a dark site. And then as you get more experience, you can try for nailing the dwarf galaxy there, just off of Regulus. So you can kind of see sort of the progression of an amateur astronomer right there, where you just identify Regulus using the moon. You come back to observe some stars that require optical aid nearby. You can enhance those observations with a telescope, and then you can really try something super challenging once you get some experience behind you to see the dwarf galaxy. There we go, Shane. Anything else to add on that one?
No, that's a great ending to Leo. I think just how you can sort of in a small region of the sky elevate or escalate your observing skills just by testing it out on a few interesting objects there.
Yeah. So Virgo, what can you tell me about Virgo?
Well, Virgo is I think one of the sweet parts of the sky for anybody that appreciates galaxies. There's an awful lot. I remember my first tour through Virgo trying to get my Messier objects that are in there. And I've never probably been more humbled at the eyepiece as I was then. I still remember it, and I still get humbled when I look through that part of the sky. And the reason is that it is such a galaxy-rich part of our night sky that if you have a wide field eyepiece and a telescope that also, allows you to see a decent field, you will have 5 or 6 galaxies in multiple fields of view. And when you just stop to think about how many stars are in a galaxy, and we're starting to discover all of these exoplanets within our galaxy, it really boggles my mind as to the potential and the size and the scale of our universe. So I really do enjoy panning through here. And I have to say too, it almost gets challenging to determine which galaxy you're looking at, because there's so many galaxies that you will see in there. Like if you're all of what we're talking about, particularly around galaxies, nebula and clusters, dark skies help. You need dark skies. Variable stars, double stars, you can do that from the city, but pretty much everything else, you really, to appreciate all of the beauty, you do need that dark sky. And Virgo is an incredibly rich galaxy area.
Yeah. So as far as location goes, Virgo is just to the southeast of Leo. Now there is another trick to finding it, and one of the challenges with Virgo is well, it's got a first magnitude star, Spica, and then there's Parima, which is around second or so magnitude. But then the other ones like Vinimatrix and Zima and all these other ones are like third, fourth, fifth magnitude to make up the constellation. So yeah, there's a couple brighter stars that you might be able to see from the city, but the other ones are going to be really faint. So how do you identify which star is actually Spica? Well, the trick that we do is we come off the handle of the Big Dipper, and I think you go about maybe 50 degrees or so. But what you do doesn't matter the distance. You arc to Arcturus, which is the bright star in the bottom of Boots the Herdsman, and it's a bright orange star. It's really prominent. In fact, if you find Leo, kind of the pointy triangle of Leo kind of points at Arcturus. And a lot of times Arcturus kind of can be mistaken for Mars or something like that. Like I went out the other night, I was just testing out some gear on my deck and I'm like, what's that? Wait, that's not Mars. It can't be. And then I'm like, that's Arcturus, right? I get a little confused because it's lower here than where I learn the stars from. So every spring when I'm out here, I'm like, oh yeah, everything's a little bit lower. So and then what you do is you speed on to Spica. So you arc off the handle of the Big Dipper, you arc to Arcturus, and then you speed on to Spica. So you just kind of keep arcing in this sort of same large, be a huge circle that's going to encompass, the sky below your horizon even, but you can kind of form this pattern along. And if you really want to find it, you can just Google arc to Arcturus and speed on to Spica. And then you're going to be able to find that. Even if you don't spell things properly, you're going to get a lot of Google hits with a lot of good finder charts for you to use. Also, the ecliptic runs through Virgo. So you can also get bright planets. Right now, there's no planets. I think there might be some asteroids and that sort of thing cutting through there. In fact, that's kind of a good place to look for asteroids if you're ever trying to see any. And then we have lots of galaxies too, of course. All right. So one of the other things there, Shane, is the Leonid meteor shower. Did you ever see the Leonids?
Yeah, I have seen them. Again, like for a lot of meteor showers, I don't actually make an effort to go out to see them. It's just I'm often out observing. So, at some point you're observing during a meteor shower, and that's one of them that I've just timed it right where I've had a telescope out and notice a lot of meteors and realize, oh yeah, it's the Leonids now.
Yeah. And I think the peak night every year is the 17th of November. Although I think in the nights preceding that, you do get some increased activity. But like with most meteor showers, they've correlated this back to a comet, and the comet that is the generator of the material that we're seeing coming in is Comet Tempel-Tuttle. And this, for whatever reason, this causes outbursts about every 35 or 30 odd years or so. And so, normally we don't get too many meteors during the Leonids. You can get some. They tend to be pretty bright. You get more fireballs for whatever reason. The material that comes off Comet Swift-Tuttle leads to fireballs. And then every 3.5 decades or so, we do get a really big sort of quote unquote storm, a meteor storm. And some of these date back to 1833 and 1889, and there's a variety of woodcuts and artwork from Germany and other places in Europe as well. There's a beautiful one showing the meteors coming down over Niagara Falls as displayed in Mechanics magazine, and made by the editor Pickering, who witnessed this amazing sight of just meteors kind of showering. Here you have basically a waterfall of meteors from the sky over Niagara Falls. On the New York side, of course, not the Canadian side. But I think it'd be too bright there now to see too many meteors. I've been in Niagara Falls a few times at night, and you aren't seeing many, but you'll see some fireworks. So back in 2003, we actually had a storm. Did you see that meteor storm from the Leonids in 2003, or was that just before you got into observing?
Yeah, I did not see it. Nope, I don't have any memory of it.
Yeah, I did go out. It was cold. It was clear and cold. I think the moon was out in the evening. And then I went to a friend's house and observed on his deck. And we saw a few meteors. But then in the early morning hours after the moon set, that's when it was going to be best. And I had a spot picked out and had gone out there many mornings to observe. It was like about a 20 or 30 minute, maybe no, 20-minute drive from my place in the city, and it was out, beautiful view to the east over the North Atlantic. It's going to be this beautiful calm morning. It was going to be cold, like cold for there, like maybe -3 or -4, a bit of wind. And I'd gone and observed there a whole pile of times, like probably about 100 times before in the morning. Never saw anybody. And when I showed up on the morning of November 17th in 2003, there was probably about 300 or 400 people there.
Oh, wow.
It was really something else. And so I, hauled my binoculars up with me. I can't remember. I don't think I bothered setting my telescope up because um, yeah, you could just like kind of look, and we did see like a lot, and it was kind of neat. It was kind of like watching a fireworks show with several hundred people, and there was like oohs and ahs, and it's right there on the ocean, and people were like all over the rocks and everything, and yeah, it was pretty cool. It was a pretty neat experience to see.
Yeah, yeah, that's pretty awesome.
So I guess I should have had that Leonid section in the Leo portion of the constellation. I think I added a couple slides in later, so sorry about that. But it's not fall anyway, so we're a ways off from seeing Leonids. So we are amateurs. I will stress that. So according to the Babylonian Malapan, which dates from about, I think it's like 1000 BC, although that number seems to change a little bit. The constellation may have just been Spica, and so instead of just being this whole constellation of Virgo and all these other stars, Venematrix and the other ones, it may just have been Spica. So kind of one of those rare instances where they had named a region of the sky. Really, it was just that one star. And that was probably what they meant by Virgo, or as they call it, the furrow. And back, in those times, they actually were representing an ear of grain, or a sheaf of grains. I always get that kind of mixed up. I should, because we live in the grain belt here. But there was this association with fertility and the crops and those sort of things. And in fact, sort of looking ahead, if we're going to talk about the constellation of Coma Berenices here in a minute, but Coma Berenices was also seen as a wheat sheaf for a period of time. So they were kind of sort of there was a relationship between these two constellations and the planting of crops. But anyway, let's talk about some galaxies here in Virgo. Shane, what can you tell us about the Virgo galaxy cluster / Markarian's chain?
Well, there's quite a few galaxies there. Some of them are Messier objects, but the vast majority are NGCs. Let's see here. So like Messier 49, 58, 59, 60, 61, on and on and on. There's so many galaxies here. What's interesting, though, is probably one of the most popular or most photographed galaxy in Virgo is the Sombrero galaxy, M104. Yeah. And it's not a part of Markarian's chain, but I think typically within Markarian's chain, there's 5 or 6 galaxies that people try to pull in through the telescope. I can't remember if they're all in one field of view or not.
Yeah, they are.
Yeah.
If your field is big enough.
Yeah, but isn't one of them like a bit of a challenge due to it not being super bright, or am I thinking of something else?
Yeah, well, some of them are fainter, yeah, for sure. But but you can see a pretty big swath. Like I remember taking my 80 millimeter out to a really dark site, and I forget the field of view. I had a pretty wide field of view, maybe 5 degrees or something like that. Anyway, and yeah, you could fit most of the chain, and then you could kind of pan around and see them too. So.
An interesting note too to help you navigate all of the galaxies in Virgo is if you have the Sky and Telescope Pocket Atlas. Towards the back of it, they have a small appendix where they
Oh yeah.
have like blow up charts of some intriguing areas of the skies. So they have the Pleiades in here and Orion's sword, but they also have the Virgo galaxy cluster. So it's a close up chart, and it is really, really helpful for navigating through here. Some other people I know that have larger apertures actually kind of simulate navigating through Virgo in their planetarium software, and identifying which galaxies they want to observe, and how they would kind of star hop and get there, so that when they're actually at the eyepiece in the field, it just they've had some practice at it already from their couch. And it may sound a little silly, but once you get into Virgo and see how many galaxies there are, especially if you have like a larger aperture telescope, it definitely can help. But you sent me an interesting
Yeah.
note a week or so ago about one of your observing friends suspecting that he may have seen Markarian's chain without any optics. That's pretty incredible.
Yeah, so Alan Whitman, who's sort of in a way, at least I think of him as a bit of a mentor, both before and after I met him, because he's one of the deep sky contributors to Sky and Telescope magazine going back several decades, and I'd been familiar with his writings. In fact, when I had to move and I was throwing out all my magazines, I actually cut out all of his articles and put them in an accordion binder. But I was actually fortunate enough to meet Alan on a few occasions, and I have been fortunate as well to do some observing with him, and he's a really great observer and really encouraging of other people's observations, and has reached out to me on several occasions to provide guidance and advice if I've written something, and he's looking to help me refine it or make a suggestion or something like that. So yeah, it's pretty cool. But I'm also on a list that he suggests I go on, and he's one of the main contributors to the list. I often don't contribute, but he and Mel Bartles and Jerry Londrigus, who is one of the contributors to that blue book that you have that you like. I forget the name of it. The catalog of deep sky objects or something like that. Anyway, but Alan was making the comment that he thought that perhaps he had seen the Virgo cluster or Markarian's chain naked eye. So they were having this really great, very long conversation over email about whether or not that was possible. Seems like if it is, it's right on the threshold. For somebody from a really dark site, they were debating it. A couple of people made some other comments and suggestions. Could be the zodiacal band getting mixed in. Could be other things. I'm not sure if Alan would have confused the zodiacal band with Markarian's chain or not. I suppose anything's possible. Late at night under a dark sky, I've seen a lot of strange things that in the light of day I'm like, that's not really maybe what I observed. But I think that is a good example of like pushing your limits. And a lot of these individuals are have several years on us, and here they are still plugging away and pushing the limits on what can be seen under the nighttime sky. So it's just amazing to read like their experiences and their analysis of their observations. So I never even thought of trying to see Markarian's chain, the Virgo cluster, naked eye before. But yeah, once we get out under a dark sky again, I think I need new glasses though. I think I'm definitely probably losing a fraction of a magnitude. So I think you're definitely going to want every advantage you can get to try to see that. But one way would be to take like our super low power 2x binoculars. And I know a lot of people have these constellation view binoculars, whether they're the ones that you make out of the Nikon lenses, or I know several manufacturers have them, would be to kind of use those and see if you can see the Markarian's chain, and then if you can see that through those, then kind of back off and see if you can kind of go back and forth between them, see if you can nail it that way. I don't know. What are your thoughts, Shane?
Yeah, I think it's worth a try. Like, this is where the magnitude scale is kind of deceiving too, I think. We've seen some stuff in under really dark skies that are, magnitude 8-ish to, even a little bit dimmer than that. But, the
Yeah.
collective light of, magnitude 8 objects that are close together, sometimes all of a sudden, using averted vision, you see it. So, you know, I'm always skeptical, but I'm also open to the possibility that things are possible. Under a night, under a dark sky, there's so many factors that play into it. There's local conditions, there's the observer's eye, the observer's experience, but I never rule anything out. And I think the best comment on all of this is, have you ever tried? To see
Yeah.
Markarian's chain naked eye, and I can easily answer that and say no, never. So I can't
Yeah.
dismiss it
Never
either
occurred
until
to
I
me.
try. Yeah,
Yeah.
exactly.
Yeah, no, it's really cool, and that's one of the things I like belonging to these different groups, whether they're a membership based group like the RASC or the AVSO or one of the other ones we talk about, or just like a very casual, informal observers list, which isn't really centralized with any group. It's just sort of like diehard observers, of which I barely classify myself as, and seldom make any contributions. But yeah, it's kind of neat to think about those things. So maybe we'll be able to give it a go here in a few weeks when we get back into dark skies again. So Spica is about 1 magnitude. It's actually it's a double star. Do you know much about the double star nature of it, Shane?
No, actually, this one I don't know a lot about.
Yeah, so I don't know. I'm not as much into the doubles, but it's a first magnitude star. It's about 250 light years away. You get to it by arcing from the handle of the Big Dipper to Arcturus and Boots, and then down to you speed on to Spica. As they say, it's quite a prominent white star, and one of the variables in the area is SS Virginis. I wonder if that will be the next star that the AAVSO has up in a couple weeks, because that's a pretty prominent one, and it's also a red star.
Interesting. Yeah, I'm looking at the Spica double star details. So Spica is very bright, as you mentioned, magnitude +1. The companion is mag 12, so it's quite dim. But the separation is huge. It's 152 arc seconds. So I think that should be doable, but quite a variation in magnitude there.
Yeah, I wonder 12 magnitude and being so close to a brighter star, that might be a challenge for the 3-inch, eh?
Could be. Yeah, I don't know. Yeah, it might be.
Yeah, cool. Anything else
Yeah.
on Spica?
Nope, that's it.
Yeah, I kind of skipped ahead there, I guess. Then I went ahead to SS Virginis, which is the variable star. Try to put a variable star into some of these, and it's a red star, varies in magnitude from a faintness of 9.6 magnitude, which would still be visible in a good like 50 millimeter or larger binocular from a decently dark site, to a maximum of 6th magnitude, so just barely poking above the naked eye threshold, and it's about maybe 15 or 20 degrees northwest of Spica towards Leo there, sort of just up the arm. But you're going to want to get a finer chart, or Shane, if you want to take this finer chart out of the slide set, that'd be great too.
Yeah, I'll post this whole slide deck to actualastronomy.com for anybody that wants to check out these references afterwards.
Yeah. And then we have Coma Berenices. Coma Berenices here. So you were observing Coma Berenices recently, I think.
Yeah, I was panning through there. There's a number of double stars on the RASC's double star list. And I even stumbled across an open cluster M53. It was pretty dim in my 76 and in the city, but definitely there.
Yeah, globular cluster, isn't it?
Oh yeah. Sorry, it is a globular. Yeah, my mistake for sure.
Yeah, and I mean, you can be mistaken because it is a really bright globular cluster. You were able to see it even from the city, and a lot of the time, the lesser globulars, then sort of that half dozen really bright set of like M13 and those ones are too faint to see from the city. And then we have the really sort of like on the opposite side. So that's just off of Alpha Coma Berenices, which is, and maybe we'll talk about the shape of Coma Berenices first. So, Shane, can you draw Coma Berenices? If you were to draw it, what would it look like?
This might be one of the few I can draw. It looks like a right angle, maybe an L, half of a
Yes,
square.
half of a square. Yeah, yeah. I guess you could if you joined up with like M85, you would
Oh
you
yeah,
would be
yeah.
able to make a full square out of it there. But none of the three stars that sort of form the points of this sort of half square or triangle or whatever you want are all that bright. I think they're just around third magnitude or so. So you need to be, I can kind of see them from the city here. They're not that bright though. So once you get anywhere dark though, it kind of sticks out. But then the big thing, of course, is the Coma Berenices star cluster, or I think it's Malat 111 there, which is just off of Gamma, or the part of the square that is on the top right or to the northwest. So, well, without further ado, we'll get into this a little bit more. So, Coma Berenices is one of the few. I think it's the only constellation that's actually named after a real person, which was the spouse of Ptolemy. And sort of as the story goes, and this is often told and retold. But the story goes that she was waiting for Ptolemy, not the astronomer Ptolemy, but one of the warring Ptolemies, to return home from battle, and made a promise to one of the gods or goddesses, and then if he arrived safe, that she would basically shave her head. And when he did arrive safe, she did so, and then put her hair in the temple and to the goddess, and then of course, what happens is the hair goes missing. And then when they went to the court astrologer to say, hey, like, what happened? Like, what did the god do with the hair? What's going on here? They made up this story about the hair being flung into the heavens. Oh, no, there it is. It's right above you. So
It's interesting.
probably trying to save themselves from having their own very short haircut. So it's kind of one of those things. But prior to that, it was actually seen as another wheat sheaf, just like we talked about. Spica being the furrow, or in some cases also being a sheaf of wheat. And if you look on the Uranometria from Johannes Baer of 1603, he actually depicts the area of Coma Berenices and the area of Malat 111, that giant open cluster that also shares the same name. It's just called the Coma Berenices star cluster, as a wheat sheaf here. So I kind of have these two images from. And they're not great; they're a bit faded, but from Uranometria 1603, showing how in one next to Boots, sort of just below Canis Venatici, which is just below the Big Dipper, you have this area that is depicted as a sheaf of wheat, and that's Coma Berenices. And then over on the chart with Ursa Major, very, very faintly, he's paid homage to Coma Berenices and depicted it as the hair. So it's kind of hard to see there, but if you kind of look really close, it's sort of got this crown, and then hanging from the crown is the hair. So he's depicted it both ways. But in this case, they're actually referring to the open cluster as Coma Berenices. But what wasn't actually a constellation until later. So I wrote up a bit. This was back in 2016 and published in 2017. And this is actually what we call the giveaway section of the Observer's Handbook. And myself and my good friend Randall Rosenfeld created a bit of an observing guide, I guess. Basically, I don't know what else you would call it, but it's a bit of observing guide to observing the open globular and galaxies of Coma Berenices. So Shane, that can be sent out too.
Yeah, that looks really cool, and lots of sketches of the various objects there. That's awesome.
Yeah. So one thing we're doing is we will never finish this project, as many astronomy projects go unfinished, but continue to publish throughout our lifetimes, is to kind of work through the constellations and what can be seen in them. And this is one of those ones that we kind of finished off and put out for publication. So lots of galaxies, lots of or the open cluster, and then the globular cluster there as well. And then there's another globular cluster of the Abell 1656 that's visible there too.
Yeah.
So
yeah,
one of the things
awesome.
one of the things I want to mention with Coma Berenices is this is kind of the part of the sky where, in a way, we're transitioning from the galaxy season to the summer, because here we have an open cluster, and open clusters are typically in the band of the Milky Way, although this one's just off band. And we're very fortunate because I think it's about the closest open cluster to us. And then it's actually in the same range or the same region as the globular clusters, which are typically halo objects floating around the outside of our Milky Way. And of course, during the springtime, we're looking towards the outside of our Milky Way, and that's how we're able to see these galaxies. But also, we're able to see some globular clusters, and then we're able to see very fortunate this open cluster there.
Yeah, there is a lot to see in that part of the sky. Not necessarily star-wise, but deep sky-wise, there's an awful lot of objects there.
Yeah, it's pretty cool. Then we have I have this on my screen. I'm not sure if you're looking at my screen or not, but I have a big galaxy up there. Do you know what galaxy this is?
I'm just switching over. I do not. So is that the black eye?
Yeah, that's the black eye galaxy.
Yeah. Okay.
Yeah. And then there's another dwarf galaxy there. There's some edge-ons. There's all kinds of different galaxies. Then we have the globular cluster M53, and then of course the Coma Berenices star cluster. And then the last thing I have in this slideshow is my sketch of the entire constellation of Coma Berenices, and then my sort of odd esoteric depiction of the Coma Berenices star cluster as an ivy leaf, as the astronomer told me to put it, and then something that looks like a very bad Dobsonian mount.
Yeah, very cool. That'll be again, that'll just be part of the show notes that will accompany this episode.
Yeah. All right. Well, do you have anything left to add? You talked a bit about some of your observations in our previous episode, but do you have anything left to add to this one?
I know we're running tight on time, so I won't get into much detail, but there are a number of really cool double stars in all of these constellations. Again, I reference people to the RASC's double star list. I'm working through that right now, and have observed a number of these, like 83 Leo, Tau Leo, and there's a few others. So if you're interested in some fairly interesting doubles, like a lot of color contrasts, and fairly easy to find and split, check out that list, rasc.ca.
And I'm going to say, if you aren't, if you have a pair of binoculars and you haven't done that much astronomy yet, this spring, go out and take a look at the Coma Berenices star cluster. Just Google it. Google Finder Chart for Coma Berenices star cluster, or go to skymaps.com. You can download their star chart there. It will guide you towards it, because that Coma Berenices star cluster, I think, is, if not the prettiest, largest, brightest, one of the easiest to find and see open clusters in the nighttime sky. It certainly makes probably the best open cluster target in the spring sky for you to hunt down.
Yeah, I think that's a great way to end it.
All right. Well, thanks so much, Shane.
Thanks, Chris, and thanks everybody for listening. Thank you everyone for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.